Hey everyone, today we're tearing down the EVGA RTX 2060X. So let's start taking this apart. It looks pretty simple. I only see a few screws on the backside, and the cooling performance overall in the review was adequate to good. So now we can look at why that is and if there are potentially any shortcomings. Before that, this video is brought to you by Thermal Grizzly's Conductonaut liquid metal. Conductonaut is what we've used in all of our liquid metal and delid thermal tests, capable of dropping CPU thermals significantly when replacing the stock thermal interface. Lower CPU thermals don't just allow better overclocks, but also lower noise levels because the transfer efficiency is increased. The mix of gallium and indium makes for a thermal conductivity of 73 watts per meter Kelvin, outclassing traditional pastes significantly. Learn more at the link in the description below. Okay, so for disassembly, we are going to be using a GN teardown toolkit. These are on store.gamersnexus.net. They are in stock and shipping now. That's right, our things are in stock. And we also have the mouse mats in stock and shipping. Okay, so 4 screws for just the cooler mounting through the PCB. There's no backplate on this card. They tried a little baby flow-through design right here. You can see an attempt at a flow-through design. I mean, this is something where typically I would like block this off, tape it off, and do a test with and without, see how much does it really matter. But right now, people are frustrated with video card content, so I'm not sure we're gonna do a separate piece on that. We'll probably just go back to other things. For other screws, there are a couple securing the base of the cooler, the fin stack, to the board. This is a tamper seal, but it's not a warranty void seal, so that's a positive. And there are no hidden screws under this sticker, just some SMDs. Okay, let's start the teardown. I haven't had any captchas pop up while trying to take it apart yet, but I'm not ruling it out. All right, so 4 screws. These are gonna have to come out. Not always the case that you have to take out these if it's securing a base plate to it, because you could remove the cooler without the base plate. But in this instance, we will have to take these out. I'll track the screws on the mod mat. I don't think I particularly have to for this card. It looks pretty simple. Just in case there's anything complicated inside, we'll track the screw placement on the grid on the mat. And it looks like we only have, oh, we've got that one there. So we're gonna take the IO plate off as well. So there are, there's a nut on the other side of both of those. They are skinnier screws as well. So those need to go specifically back in the IO plate. And then here we have 3 smaller screws for the display outs. I'm gonna grab a Phillips 0. Actually, that's a Phillips 0. We'll grab a Phillips 0 from our toolkit. These have pre-magnetized, tips, although they don't magnetically stick to your hand. So if you're gonna fumble it, that will still happen, unless you're Linus. I'm pretty sure at this point he is actually a robot. So that might be the way I can make that determination next time. See if our screwdriver sticks to his hand when he pretends that he's a human and not just some deep learned AI with an army of AI scriptwriters. He says he has a lot of employees, but don't believe him. All right, that should come apart. Yep. Cool. So very simple card. We can analyze this once I disconnect the fans. Okay, I actually really like this. It's such a small feature, and I'm not sure that they even do it intentionally to help you as a user, but it does nonetheless. A lot of the time, the fan headers for video cards, they don't have these clips on them. These clips, you can just push it and it'll release from the housing like you would expect. But a lot of video cards, they have those really form-fitting connectors and headers, and the end result is that you really need to be careful removing it, because you can rip the wires out very easily if you're not pulling in specifically the right place. So these are better done than a lot of the ones we've seen, which is kind of, sadly a positive side. Very small one, but one that makes it easier to repair things. So for assembly internally, we've got some thermal pads. Let's measure the thickness on those. In case anyone ever does maintenance on this in a few years, we're can get you the thermal pad size so you can replace them. Sizing on these is 2 millimeters. That looks about right. And let's see if that's the same. That one's maybe 1.5. Harder to measure though. Heat pipes look like they're 6 mil heat pipes. Very simple design. Not as much heat to cool on this. It's a 200 watt card. It's about 170, 185, depending on the OC condition. And it's just 2 heat pipes going through the center of the die. So if you wanted to get more expensive with your cooling solution, oh, I just noticed the marking on the board too, then you would want better coverage. It looks like 4 6 mil heat pipes would connect pretty well through the entire silicon diffusion barrier, but they've gone with 2 in the center. So it's not optimal, but it's optimal for keeping it close to MSRP, which is hard to hit at these for the board partners on these cards. Now the marking I just noticed that I'm not going to spend a ton of time on because I don't know what it means, but there's a marking right here. In the past, we've asked EVGA specifically about these marks when they show up on GPUs on the substrate, and they tell us it's a QC mark and not a binning mark, but just it works or it doesn't work. This one did work, but not sure what else that would be. Just kind of interesting. It could also be something as innocuous as just making sure it lines up properly with whatever, maybe the cooler, for example. So back to the cooler. The solution has the GPU positioned mostly centrally. There's a copper cold plate that contacts directly to the diffusion barrier. That copper plate is connected to the 2 heat pipes, and the fin stack is welded onto that as is usual. And those heat pipes end up coming back through the copper plate the other way, and actually running through on this one the memory area, and this one the memory area, but we don't have any coverage here. However, let's see, that is okay because there are no memory modules here. So it's 3 on the bottom, 3 on the side for the memory location, and then the VRM ends up over on the left side of the board near the I/O and is right below a fan, which is a big positive. The MOSFETs are contacted directly to actually a copper plate. This is uncommon. These are typically aluminum plates. So there is technically a copper plate there. Now, it's a little bit inefficient because there's an interface changeover. We're going from this copper plate back into aluminum for a plate that goes to the fin stack, but that's a little bit better solution than we normally see on a card of this class. On this side, there's not a lot of contact to what I'm assuming is the memory VRM from the heatsink, but it's just 2 inductors, and those can withstand some heat. They can be air-cooled anyway. Flow through there, and otherwise an 8-pin, pretty simple stuff. Replacing the fans wouldn't be too bad on this one. So to do it, you would take the fans are going to have their own 3 screws. So there's like 1 screw right there, for example. There's 1 over here, and there's 1 over here. So you would take those 3 out, and you probably want to take the shroud off too. There's a screw for the shroud right down there, and then there's going to be 1 over here, and then 1 in each of these corners. And I think it's just 1, 2, 3, 4, might be 6 screws. That would pull out, and then you'd be able to replace these. Each wire is independent, so they can be replaced individually, which is a good thing. Thermal paste application looks good. Overall, fairly even spread and contact. You can see actually, if we look at this, that they are silk screening the thermal paste onto the cold plate so that they have a wide area where this can be done by machine. I don't know if EVGA's third-party factory is doing it that way. It's often done by hand too, the silk screening of paste. You see that, for example, with AMD's stock coolers, when we saw those getting made in 2019, that was all being silk screened by hand. So not sure they're using a machine for this, but using a silk screen, it uses a hell of a lot more paste, which does increase the budget a little bit. You get dinged every time you do that, but it also means that the room for error in applying it is much wider, so a little bit beneficial there. So here you can see that the pad that stayed on the inductors, which is actually the only pad on any of them, this is cheap. This probably the entire row here should be contacting. I mean, it's not that expensive to get it to come into contact, but anyway, this one pad You can see the impression from the heat pipes. So that's their direct cooling solution for those 2 inductors. Doesn't take care of the others, but those are gonna be the hottest. The others, inductors can take a lot of heat. It's like 125, 150C. It's just a copper coil inside of a shell anyway, but would like to see that fully contacted. I'm staring at this board and I'm not seeing a shunt resistor. There's only a 5 milliohm shunt resistor for these power headers that you can short or piggyback if you want to get a higher power limit without doing a custom BIOS, but I don't see one over there. We'll look at the back in a second. Over here there is a fuse. So you can probe these to determine if the fuse is blown, and that's useful in troubleshooting if you're getting a red LED, which I think we've covered with our inventory code. But well, actually this card doesn't have one. Some cards have a red LED on the back for the 12 volt, and if the fuse is blown, that'll light up. And then if you want to verify if it's the fuse, you can go measure it. There's a shunt resistor right there. Okay, so that answers that question. There's a shunt resistor. There's another one that's going to be for the slot, 12 volt down here. Don't short this one if you short any at all, because you don't want to pull more power than spec through that power slot. And then finally, for memory, they are using Samsung memory modules for this one. That doesn't mean they're all going to be Samsung, but good indication of at least starting that way. I'm going to clean off that GPU die. NVIDIA GA106-300-A1 is the SKU. If we ever see something like a GA106-350, it might be, for example, a super model of this. Supermodel. Let's rephrase that. Let me rephrase that. If we ever see a GA106-350, it could be a super SKU of this card. However, it's also possible that they end up going up a class to a 3070 and cutting it down to a 3060 Super, in which case it would be a 3070 GPU or 3080 GPU or whatever they end up doing physically, but internally fused off. Last thing I just noticed, kind of interesting. So over here on the sticker for the cold plate, so we just checked that QR code too. It's just a serial number, nothing interesting, unfortunately. Well, that's it. That's the XC Black Edition EVGA card at MSRP asterisk in theory. So that's it for the RTX 3060 XC Black. If you end up catching one of these in stock, at least you know how it's assembled and how it performs in the review. But otherwise, like I said, it's ethereal in its form, and it's a little bit, as we said in the review, disillusioning to review cards that we know a lot of people might not be able to get anytime soon. So hopefully this helps those of you who can get one, or help someone in the future when they get one and they need to disassemble it or maintain it, the fans, for example. But that's it for this. Thanks for watching. You can grab one of the toolkits that we used in this video on store.gamersnexus.net or patreon.com/gamersnexus for behind the scenes videos. And we'll see you all next time.